Hi everyone, in this video I'm going to show you how you can use a 555 timer to make a latching circuit. So now as you can see, I set the output voltage to 12 volts, and as you can see there's no current draw. Okay, so as you can see now it's wired up. Let's see if it really works. This circuit that I just build them up in mid-air, and it looks like this. So let's turn on I turn on the power supply and see if this switch works. Okay, it works. One push off, one push on. So what I'm showing you is that I can use this momentarily switch to latch an LED or a circuit on and off. So this is the schematic for my circuit. So just to explain how it works, in this case I use a 12 volt power supply for demonstration, and the main component is the 555 timer or the 555 timer. So in the first place, current will flow through the 15 kilo ohm resistor, which is connected to both pin 6 and 2, the trigger and threshold pin, and down to this 15k resistor and back to ground. So because these two resistors value are the same, therefore we will get a 6 volt supply over there. And a 6 volt supply over here. And this resistor divider over here, 5 kilo ohm each, is what gives its name of the IC chip 555. So basically this part here will receive 1/3 of its supply voltage, which is 4 volts, and 2/3 of the supply voltage here, which is 8 volts. Because these two triangles are comparators, the not inverting input must be higher than the inverting input to turn this comparator on. So what happens is that the plus input is lower than the minus input, therefore it turns off. So it's a 0 here. And same in this case also, plus input lower than minus input, output is still 0, and nothing is set on the flip-flop, and therefore the output is also 0. So you got your 6 volt supply. When I use my oscilloscope to probe at pins 2 and 1, so when that push button switch is pressed, the capacitor gets charged up very quickly. So the voltage dips to 0 volts momentarily and back to 6 volts, because the voltage across the plates of the capacitor cannot be changed instantly, so that's why. So the moment when this non-inverting input is at 0 volts and pin 6, which is connected to this non-inverting input of the second comparator, is 0 volts, only then the output at the first comparator is high, so it's a 1. And the output is a high, is a 1, and therefore the LED is illuminated. However, at the same time, current flows through the 100 ohm resistor and charges up the 1 microfarad capacitor over here to a voltage of about 10 volts. So got to remember that there's 10 volts across the plates of the capacitor right now when the LED is turned on, of course. So for the next case, when the push button switch is pressed once again, the LED will not be latched on anymore, it will turn off. Well, when the push button switch is pressed, the capacitor, which is charged at 10 volts, will appear at the pins 2 and 6. So on the oscilloscope, we will see it like this, 10 volts. So 10 volts here and 10 volts there. What happened now is that for that first comparator, the plus input is lower than the minus input, so it sets the flip-flop to 0. On the second case, it resets the flip-flop. Well, that is due to the plus input being higher than the minus input, so it resets the flip-flop. And as you might know, when that flip-flop is reset, the output turns back to 0 again, and thus the LED turns off. And as for the charge of the capacitor, the voltage across the capacitor would drop from 10 volts down to 6 volts. So it will be, so when probe from pin 2 to 1, it will go back to 6 volts again. So I hope you enjoyed the video. If you do like the video, please give it a like and please consider subscribing to my channel. Thank you very much and goodbye.